Welcome to the fourth video on networking. As you recall, the first video in the series is a basic introduction, what's going to be covered and why it might be of interest to you. The second video provides some background on internet protocol, how IP addresses work, how net masks work, how virtual LANs work, things of that sort. The third video is on networking, specifically routers, firewalls, and how to set one up. And that's where I go through the full setup of what I consider a very nice community edition free firewall and router. And this video introduces the concept of running your own cloud. The nice thing about a cloud is that it's a great place to store your data, both from a redundancy viewpoint and also from a sharing viewpoint. So you can have a client on your Windows or Mac laptop that will automatically take any files that you create or use and store them on the cloud. And if you lose your laptop, all your data is still on the cloud. And if you're sharing with family, with colleagues, you can share your data with, or at least the parts of the data that you want to be sharing, with the people or the groups that you're interested in. So, for instance, if you have a bunch of music and you want to share it with your family, you could have a group that's called family and set the entire music directory to be shared by family. And sharing can be read-only, or it can be read-write, or it can be full control. Similarly, if you're running this in an office, you can have the sales team sharing directories or multiple directories so that everyone in sales can see them. Or you could have the full company have access to certain documents, or an individual person. And again, this is per directory or even per file. So it gives you a great deal of control over who gets to see what when. And the best part is it's all on your system. You own the data, you control the data, you decide who gets to see it, who doesn't get to see it. And nobody else, no big company gets to do training on your data. And they don't get to decide if for some reason you're using too much or you should no longer have access or what have you. To do this requires that you run a server. And in this video, we'll talk about setting up a server. And specifically, I'll be setting up Linux. It doesn't have to be Linux. It doesn't even have to be, it could be on a Windows machine if you want, but then you have to figure it out on your own. I'll be setting it up on Ubuntu because I think it's probably one of the easier Linux distributions there are. And I'll be setting up pretty standard. And on the way, I'll be trying to go through the kinds of things you want to be looking for. To do this, you're going to need a server that can do this, which is a fancy word for a PC that you may want to have ECC on it. That's error correcting memory. The nice thing about that is if you do get a memory error while you're reading or writing data, your data won't be corrupted because the memory error will be corrected. You'll want to make sure you have enough capacity for storing hard drives based on how much data that you want to store. So the absolute minimum that would make sense would be 10, 20 terabytes of data, which is already a fair amount. And that would be 2 hard drives because you'll want to have redundancy. So if a hard drive crashes, you don't lose your data. And that's where we talk a little bit about storing redundantly. And I'm going to be talking about ZFS, which is a disk file system. And ZFS, like some other file systems, but I happen to like it a lot, is great for error checking and redundancy. It can be set up as a RAID, and a RAID is a way of having multiple hard drives that store your data, plus an extra hard drive that carries parity. And the idea is if you might have 4 data drives plus a parity drive, so you'd have the capacity of 4 drives, even though it's costing you 5. And if any one drive fails, well, you just replace that drive and the parity is used to go and rebuild the drive that failed. And that's pretty good. It has advantages and disadvantages. The advantage is it's not very costly in terms of overhead, because if you've got 4 data drives and a parity drive, it could be 5 or 6 or 7, however many you want. And so you're getting almost full usage of your drives. You're not paying a lot of overhead for the parity. It has some disadvantages as well. Namely, if a drive fails, then there's a long rebuild process. While after you put a replacement drive in, it's got to go and rebuild the entire RAID system off the parity drive in order to recover. RAID 10 gives you a spare parity drive in place, ready to go, so that you can immediately continue, and the rebuild process isn't as critical. Even when a drive fails, you still have parity. You can suffer 2 hard drive failures before you'd actually lose data. And the third one is mirroring. And that's the one I prefer, and I'm going to go demonstrate how to set up with mirroring. And mirroring is basically a 50% loss of hard drive capacity. You'll have 2 hard drives, and they store the same data. It's faster, it's simpler, it puts less load on the hard drives, and in my view, hard drives are one of the least expensive things out there, so just buy 2 of them and know that your data is safe. One of the great things about ZFS, and I'll mention this again somewhere in the video, I'm sure, is that once you have your data stored on ZFS is really nice because you can yank the hard drives out, you can put them in a new system, and you can import the data, and all of your data is just going to be there again in your new system. No issues about was it mounted right or anything of that sort. There's no needing to write back to the drive. The ZFS is robust in the sense that it checks that everything is correct, writes it on the disk, and makes sure that it's completed. At no point is this disk in an unknown state. And that means if you get a hard crash and your system just totally dies on you and you're mirrored, you can simply take one of those 2 hard drives, plug it into a new system, and rebuild everything from there, and all of your data will be there. And so one of the things that we'll be going through here is looking at a system where there's one drive, that's the system drive. That's where the Linux operating system lives. That's where your home directory lives. That's where all of the programs that you install live. And then there are specific ZFS drives that are used just for your data. And that's where I'm going to be talking about a product called Nextcloud. It has a community edition, so you can use it for free. It's well supported, and it also has commercial applications that can be mounted on it as well. So the community edition runs basically your cloud data. In addition, they sell documentation, so you can have Word and Excel types of functionality, mail, and a chat function, so something like Zoom. And those are particularly useful if you're very privacy concerned. Then you can basically be running Zoom, documents, email, all of those inside your organization, only for your organization. You know that nobody is sending you hacked emails if you're only looking at the emails coming from Nextcloud, and that Nextcloud is running only in your local organization. Similarly, you can now have meetings and chats where you know that no AI is training on your data, no company is looking at your data, no breach, unless it's a breach of your own system, is likely to happen. So in highly secure environments, I would recommend that you be running everything on Nextcloud, and the only remote access in is going to be through either SSH with keys or a VPN that you're running. And if I didn't talk about that in the third video, which I may not have, then I could certainly add a comment. I can certainly have one in there. How do you set up SSH so that everybody gets in securely? SSH is basically a VPN. It allows you to have a highly encrypted, very secure connection. And this is SSH using authorized keys, not username and password. So you have an authorized key. So each laptop that's trying to get in has its own key. And so that laptop, you're not a username and password that you can break. That key lets you in. Similar to a VPN. A VPN is usually a little bit more general, but both of those allow very limited access in. So in a highly secure environment, the only way you'd be getting into your network at all would be through either SSH or VPN. No port 80 open, no port 443 open, none of that. And then your mail, your chat, your documents are all living inside that network where the only way in is through a VPN. At that point, your documents are going to be very secure. And even when you have a variety of people coming in, they're all coming in through VPNs or SSH. So they're all authorized to come in, and now no third party is going to have an easy path into your system. So with that in mind, let's go take a look at how you set this up. I'm setting this up on a very straightforward Ubuntu system. It's going to have one system hard drive and two data drives that I'm going to set up ZFS mirrored. And once those are set up, I'm going to install Nextcloud and get it to the point where Nextcloud is running, and you can see where you can add users and add groups and things of that sort. In all cases, I recommend that while I'll show you work with you through the basic steps, you'll also want to be reading the documentation, particularly around Nextcloud. If you want to be doing anything other than, if all you're doing is just basically storing your stuff on your cloud, you'll probably be all set just like that. Just install your Windows client or your Linux client and you're good. If you want to be doing any more advanced types of things, setting quotas, allowing certain users certain access, allowing other users other access, well, the documentation is excellent. So I would highly recommend you use that. And for Linux, Linux is a large, entirely, you can go on forever with whatever you want to do on Linux. So I'll be concentrating just on a few things. Installing Linux, updating Linux, which is something you'll want to do frequently, every week at the latest. Do an update. Just, are there any software updates? Get them. And installing ZFS, because you'll need to install that separately, and installing Ubuntu. And pretty much nothing else. So I'll also show you how you do ZFS, what's called scrubbing. So you want to do a ZFS scrub. It'll go and check to make sure that your hard drives are all good. There's nothing corrupt. There's no indication that there's time to replace a hard drive. And that's going to be all I'm showing you in Linux, which is very basic. It's going to be just a server. There are any number of other things you can do with it, but keep in mind that this is really a cloud server that is accessible from the outside, then you really don't want to be doing much with it. You want to have it just running that and nothing else. Every time you add something else to it, you add a little bit of a security hazard. Of course, I'm saying that, but the fifth video of the series will be talking about running your own security cameras and security camera software, which also runs on a Linux machine. And now you're going to have that trade-off of cost versus security. Do you put them both on the same server? Well, if you're a home user, the answer is probably yes. Do you really want to own a second Linux machine and then have them doing separate things? If you're more concerned about security, then the answer may be different. Then you may want to have your security camera Linux box be on a completely separate network with your security cameras that don't get anywhere near your cloud server. And that's a trade-off you get to make. I can't make it for you. The third video on networking should give you all the different options of how you might do that and the pros and cons of each of those. So, with all of that said, and probably a lot more, sorry this is already too long, let's go set it up. All right, so we're going to try to install Ubuntu server, and we'll do that by hitting carriage return when it comes up. This is straight from the ISO that we loaded. And as before, you'll get all kinds of lovely messages, and it'll take a little while. And we can skip some of this because it's going to go for another minute or two. And it'll come up with menu options, and we'll want English. That. And the keyboard label, and we want Ubuntu server. And this time what we really want to do is Ubuntu server minimized, and that's going to just have smaller footprint, fewer software things in there, fewer things that can be attacked. So it just keeps it as clean as possible. We're going to load everything that we need to have, and click done. And it can go and connect up to the internet. Well, to the particular one in there, no proxy in there. And for So now it's going to go and download all the software it needs. So the ISO just has sort of the minimum boot, and then it's going to go get all the other packages it needs based on what we specified. We specified minimum, so it won't be too many. Set it up as an LVM group. So this is the important part. We want to go and grab the correct disk. Dev SDA, it looks like the right kind of hard drive to be using. Especially if you have multiple drives put in that are going to be used for data, make sure you use the drive that you want to be using for your system to load the system on. I like to have separate drives for all of the data because those are the ones that I'm going to want to have duplicated. Those are the ones I want to be able to pull out, so on and so forth. And in this case, I'm going to let it go. Normally, if you were doing some kind of heavy loads, and you might look at adding more swap space or changing partitions. In general, if you've got a reasonable size drive, you'll be just fine with this. Red for continue because it's basically going to wipe that system. And test. Server's name is test, and we're going to have a user named test whose password is test because I'm so original. Ubuntu Pro can be nice. You can get, I think, 5 machines on Ubuntu Pro for free, and it basically keeps you a little more up to date and does some number of updates without you needing to reboot. That said, I can only recommend that you regularly do updates yourself, and we'll talk about how you do that after we get a little bit further in. OpenSSH server is a good thing to have somewhere. You probably don't want to have it on this machine. Well, you might. I'm going to put it in for me, but I'm not going to put in authorized keys yet. And the only thing I do not want to install Nextcloud here. I want to install Nextcloud on my own later. I'm going to put nothing else in here. So I'm going to put nothing in at all. Nextcloud is what it's going to drive, but I just soon have it run by me, not run by Ubuntu. And we proceed with this system install. So once your system is installed, we're going to do a reboot. And if you didn't unmount your CD-ROM, you're going to get an error in that. And in this case, it's a virtual CD-ROM, so that won't really work. So as it's rebooting, you'll see all kinds of things start up. And so it's always kind of noisy on reboot. Just get used to it. And we now have our lovely options for test. And we get a prompt. So the first thing we're going to do is to do an update. As an update, you need administration rights. And I encourage you to look this up, but I'm just going to tell you how you get to administrator. And the command is sudo, which is super user do. And we're just going to run sudo bash. And bash is a command prompt. So what that basically does, and we have to put in our password, is give us a root access to this machine, which is the equivalent of administration rights. And now we're going to write it's really 2 commands, apt update. And update basically goes out and finds out, are there any updates to be done? And let that go run for a little while. And it'll go check all the different archives. And generally, when you put a new machine in, there are going to be lots of things going to be updated from the ISO. apt upgrade, and it'll ask you for every single one. So I do a -y, which basically says respond to yes automatically. So just do it. Don't ask questions. These are the 2 commands you want to be using frequently. apt update followed by apt upgrade -y, and that is basically doing an update on all of the software for this particular system. And now we're going and getting all the updates. And once all the updates are done, sometimes it'll ask you to reboot, sometimes it won't. If it says that your Linux is out of date, then you will want to do a reboot. Sometimes it'll just say reboot required. If it says that everything is up to date, then you're good. You don't need to reboot. And so here you can see that the running kernel seems to be up to date. That would be the main thing to be looking for to see if you need to do a reboot. And here it looks like we don't. So nothing is outdated, and we are good. So at this point, we have the fundamental Linux prompt. So once we've done that, we want to install the ZFS, which is going to be the file system I've talked a little bit about in the earlier episode. And that's going to be an apt install. An apt install is the command used to install new software. And so here it's going to be ZFS utils hyphen Linux. If we do that, it's going to go and add 7 gigabytes of data, and we're going to say yes on that, and off it goes. Now we actually have ZFS, and now we can begin to look at how we install ZFS for the data. So this particular machine has 2 hard drives. As I hopefully talked about earlier, when you use ZFS, the nice thing is it gives you redundancy in a variety of ways. You can now have a either a full mirroring, which is 2 drives holding parallel copies of all of your data. That has a bunch of advantages. If you lose a drive, well, you just keep on operating because the other drive is there to continue, and you can then take that drive offline and install a replacement drive and just keep on going without ever bringing your system down. You can also use RAID 5 or RAID 10, which will have some number of drives, a minimum of 3, I believe, but you usually use 4 or 5. And for RAID 5, one of them will be a parity drive, so that any one of those drives can go down, and you replace the bad drive and you put a new drive in, and then it slowly but surely rebuilds everything so you have all the drives plus parity again. RAID 10 is similar, except it has 2 drives for parity, so one of the drives can be taken offline without affecting the other one right away. A couple disadvantages with RAID 5 and RAID 10 is that in the event of a failure of a hard drive, the entire system has to be rebuilt. It does it automatically, but it has to be rebuilt by rewriting the parity information on the new drive that had from the old drive. So it puts a very heavy load on the disks while the rebuild is being done. Some people recommend not to use that. I'm not a hard drive expert, but people do recommend not to use it just because of the potential of failures during the rebuild. I also like mirroring because it's faster. When you're doing a write, the write to 1 is good enough for it to go. When you're doing a read, it'll get your data from whichever drive is closer to. You usually have to wait for the disk to come around to the head. One of them is likely to come around sooner than the other, and you get to continue operating as soon as one of them does. For me, mirroring is simpler, a little bit more robust, and given the cost of hard drives these days, not that much more expensive. Anyway, let's go continue this into building Linux. What we want to do is see what hard drives we have available. And the hard drives are in change directory to /dev. And in here you can see all kinds of stuff, but really what we want to do is look at lssd star. And we can see we have SDA, that happens to be the system drive, SDB and SDC. SDB and SDC are the 2 data drives that I'm looking at using. And just to look at them, I tend to use fdisk. It's an easy way to look at it. /dev/SDB and print. And so we can see that it's a 6 terabyte drive. It's got 5.46 available, and it was partitioned by Windows, obviously, since it has Microsoft Reserve and makes basic data, but that's fine. It's an empty drive. And just because I like to check, we're going to do the same thing, /dev/SDC. Make sure that that looks good. And it's also a 6 terabyte drive, so great. So I've got 2 6 terabyte drives available. And this is where ZFS is going to be perfect for setting a mirrored drive. That will have both drives containing the same data. That'll give me 5.5 terabytes of usable data that is completely redundant, and ZFS automatically checks for disk errors, and both on the reads and the writes, to make sure that any write that you do to it is safely put on both drives, and it'll give you an error if anything goes wrong. And I'll show you a ZFS scrub where it goes and makes sure on a regular basis, once a month, that in fact both drives are working well, to give you a little bit of a warning if there's anything wrong. So let's do a Z pool status. We haven't done anything yet, and so no pools available. Perfect. So now I want to do a Z pool create. And by the way, ZFS and zpool, these are standard, and I really recommend that you go and look up how to be using ZFS on Linux. I'm going to give you the commands you need, but anything outside of this very direct set of operations you'll want to be doing on your own. So I'm going to do zpool create dash options, and I'm going to do an A shift equal 12. I'm going to let you look it up. It's basically an efficiency thing. And I'm going to call it Z data, my data. You're giving the pool a name. And in this case, I'm going to do a mirror of SDB and SDC. Those are the two drives I want to be using. And we now have it. Now, if I were to Z pool status dash V, verbose, I can see that I have a my data, and it's a mirror, with SDB and SDC. I haven't mounted it anywhere. It doesn't really exist. I can do a DF, which is list disks, and I tend to do H, which is human readable, so it gives it to you in megabytes and gigabytes rather than in some crazy long numbers. And basically, I can see that I have dev SDA2, and that's kind of it. So there's no my data, there's no ZFS data mounted at this point. Now, here are some things that I am going to recommend you look at. ZFS set deduplication, no space, equal off of my data. That turns off. ZFS will do a deduplication, which can be nice. It takes a lot of CPU and memory, and we're using this for data structures. Do not do any deduplication, please. ZFS set a time equal off my data. Now you can set record sizes, and that tends to be a good idea to set the record size a little larger. You could do a ZFS set record size equal, 512K, something like that. It will be a bit more efficient than the default. I don't know what the default is. 4K, something pretty small, and this just makes the records bigger. So if you tend to have larger data, it's a good idea to do this. If you're going to have a whole bunch of files that are 1 byte long, then you probably don't. Right now, I'm not going to worry about that. That's something you can look at. So we can now do a zpool scrub my data. And this basically says, check and make sure that the disks are healthy and clean. And I recommend you look up on your favorite browser to find out what that actually does. And now if I do a zpool status -v, we can see that the last scrub took no time at all because there's no data on there. There were 0 errors. And when I do the scrub, it'll automatically do it every month or so. So at this point, we have a 5.5 terabyte drive. You can create subpartitions. So you could do a ZFS create my data / my partition. I'm not going to, but this is what you would type. And then you could even set a quota of that partition. Say that partition cannot get bigger than whatever it is you want to have. Now we have a ZFS pool, and that pool has about 5 point some terabytes of data available in it, but it's not mounted, as we just said. And where do we want to mount this? Well, that depends on what you're using. So Nextcloud has a default place where it puts all of its data. So there are really 2 possibilities. You could mount the pool, the ZFS pool somewhere, and then have the Nextcloud data point there, or you can simply mount it where Nextcloud automatically puts the data anyway. And that's what I'm going to do here. So inside Snap, we're going to want to create a directory called Nextcloud here. And it's important now that we are root, so that this is all owned by root. And inside Nextcloud, cd Nextcloud, this is where I'm going to want to have a directory called common. And common is where we're going to store all the data. So common is the thing that's going to own, it's going to be the ZFS pool, so that all of our common data, which is all the files for all of the users, everybody using Nextcloud, including all of the backups and previous versions of things. So Nextcloud will keep versions of files as you edit them, will all be stored inside common. So here is where I want to do a mount of the ZFS pool. So I want to do a ZFS set mount point equal /var /snap /nextcloud /common of my data. Oh, in here, oh, that's not very helpful. ls --auto color equal never, and this really only happens when you're running at the beginning. We see common, cd common, color equal never, and we have nothing in there. So now we have the common directory set up, and now I want to do a snap install Nextcloud and let it go and set up the system. So it'll go and get it all and make sure that it's all up to date and install it. And now in common, we should now see the directory Nextcloud. So if I go make sure that I'm in common, df, that's a show how much space is available on all the disks, -human readable dot this directory. And you can see I have 5.4 terabytes available. If I go up a directory so that I'm up in Nextcloud and I do the df-h dot, I can see I have 100 or whatever it is, 46 gigabyte size. So Nextcloud Common is now holding the 5 terabytes of ZFS data. ZFS has a lot of advantages. You can expand it. If you're beginning to run out of space, you can just add more drives and add them to the pool, and suddenly your pool is big. And as I said before, anytime you get any kind of a disk failure, you can just simply replace the disk, and Nextcloud doesn't care, your data doesn't care, you're good. If your entire system fails, you can yank those 2 drives, or even just one of those 2 drives out, import it into a new system, and you have all of your data back and intact. So that's what makes ZFS really nice. It's robust. It's capable of surviving a whole variety of failures that any other normal file system would not. Easy to import, easy to export, easy to go move it elsewhere, and failures of pretty much any sort are okay. You can recover from them. Once Nextcloud has been installed, we can go get a browser on some other machine and point it to the IP address of the new Linux system, and it'll bring us here where we basically have the setup. The setup form is pre-filled. We're going to set something up here. We're going to have an admin and the account password is going to be something. The good part is it doesn't like things like this, though. It's actually very weak, but we'll take it anyway because right now I don't care. But what you want to do is make sure you've got a good username and password and you remember them, because I'm not sure I'm going to remember this one. And there are a bunch of apps that you can put in to Nextcloud. It allows you to run your own mail system, which is really nice. If you're going to keep things completely inside, then you can have mail, contacts, calendar that are going to be safe to use between you and the other users. Office allows you to have spreadsheets, documents, and things like that. And it's nice if you have a really enclosed system that you know that emails coming to and from you on this system are going to be, in fact, from you. There will be no spam, no people claiming they are who they aren't, because it's all on your system and only there. And so you can choose which ones you want to install. We're just going to skip that for now. I highly recommend that whatever you do, you go and read the Nextcloud documentation. It's really good. And this is actually a fairly complex system, but it's got everything you might want to have for a collaboration environment. It also allows you to put the Nextcloud on each device. You can have clients on Windows machines, Mac machines, Linux machines that allow you to access your data and get all of the productivity tools that you would choose to be using. Again, I'm going to ignore that for now. Once you're inside Nextcloud, we have an administrator, and here is where we can create accounts. We can create groups. We have administration settings. We can share files. We can say certain directories are kept within certain places. So here I can have an account, and I can add and I can add groups. So if I want to create a new account, then it's going to have the account name and all the usual kinds of things. So this could be user one, it should never be called that. They can have their own display name and email address so that you can reach them. They can be parts of groups, so you can have an administration group, you can have various, however you want to organize that. If you're using this as a part of an office environment, then you may have marketing separated from sales, separated from whatever other IT, what have you. If it's a family one, then you may have one for extended family. You may have one just for the kids. You could have whatever you want to have there. One thing you always want to think about is backups. If you are doing backups on every single client machine, well, that may be sufficient, especially if you are always synchronizing every file in the cloud. However, there are a couple things going on. One, you may only want to have some of your files and directories from the cloud on your client machine, your Windows or Linux or Mac OS laptop, and have a whole bunch of other data that is only sometimes used. And you may have multiple users. And in either of those cases, that means the data that you want to be backing up is actually all on the server where the Nextcloud is actually running. So let's take a look at where that lives. Assuming you installed it via Snap, then in cd/var/snap/nextcloud, we see 51274. That happens to be the current version of Nextcloud, and current is just a link to 51274. That's the current version of Nextcloud, and when it doesn't update, you'll see previous versions as well. And common, if you recall, is where we put our ZFS directory. So inside common, we'll see a directory called Nextcloud, and if we go into Nextcloud, we'll now see individual users and data. And inside data, we see individual users. And there we have a single user called admin, which is the user we created, along with the data that is used by Nextcloud to run. And so if we look in admin, we haven't created any files yet. So we just have the default files. And those files are, they create automatically a documents directory and a Nextcloud introduction video and the photos directory and their usual things. And usually what you do is you could delete those and put in the stuff that you want to have in there. If we were to create multiple users, then we would see right here, we'd see admin, user 1, user 2, user 3. And as you can see, this is a great place to be doing backups. So what I tend to do is back up right here. I grab common and I back it up. And right now, you'll note that when we look down in the files directory, we could see that we had files that we could read. readme.md, that's just a text. There's Nextcloud intro, some kind of movie or whatever that is. And a reasons to use Nextcloud is a PDF. The other thing to be thinking about is encryption. Right now, there is no encryption whatsoever, and you really have 1, 2, 3, 4 possible things you could think about encryption. One of them is you don't encrypt. You just leave it like this, and everybody's on their own. Another possibility is that you have users encrypt their own data using a third-party app, such as Cryptomator would be one example, where Cryptomator will just say, encrypt this entire directory on down. The user manages it on their PC, and they then store encrypted files in the Nextcloud directory, and it's completely outside of Nextcloud's control, and that user is now responsible for making sure they keep their key. You lose that key, you lose your data. You can now, in the backup, you would be backing up encrypted data, and that's actually powerful. The encryption is going to be good. It is by definition end-to-end. It is being done on their PC. And Cryptomator works great on PCs. My experience with Cryptomator on Mac OS is not so good. You either have to use MacFuse or FuseT, and I've found both of them to be kind of unreliable. On Windows, it uses WFS and works great. So your mileage may vary. That's just my experience. Nextcloud supports two different types of encryption. One is server encryption, where all files of all directories of all users are encrypted at the server. That has some advantages, particularly if you want to be sharing encrypted files or encrypted directories between multiple users. Nextcloud supports a fair amount of that. The disadvantage is that it encrypts everything. Maybe that's good, maybe that's bad. If you are encrypting everything and you're looking at doing a backup, well, you're going to get the entire backup. It will be all encrypted because that's all the way the files are all done. There are some advantages and disadvantages in terms of security, where some of the security is at the server, which has the big advantage of you can recover files, you can look at files, even when some user has encrypted them. So in a corporate environment, that could very well be important. Note that leaves some weaknesses if your backups are being done off-site along with your security keys. Then conceivably, again, advantages and disadvantages. The advantage is that you can recover with the security key from an off-site backup. The disadvantage is that whoever can get access to that offsite backup can decrypt. The other option is what's called end-to-end encryption. And that's done at the client side. That is, at the Windows client or the Mac OS client, the user can specify a empty directory, and they can say, that directory, I want to have it encrypted, and then there'll be a mnemonic that they use. It's, 10 words that are all put together, one right after the other. And as long as you have that mnemonic, you can decrypt that directory. That also has advantages and disadvantages. One of the main advantages is end-to-end encryption means that nothing other than the user can decrypt those files. Well, anyone who has that mnemonic. It also means that from that end user laptop, everything is encrypted and stays encrypted to the server, and then any backups being done are all encrypted as well, and they're only decrypted when they come back to the actual laptop of the user. That will work well across Windows and PC, so if the user is using both, as long as they have the same mnemonic, they can see all their files decrypted at the PC, and then everything is encrypted afterwards. That's the method I prefer to use, because it means that I can encrypt specific files or specific directories. Not specific files, it's only a directory. And that means that my pictures are not encrypted, and I don't really need them encrypted, and anything that is not sensitive is not encrypted, and that means it can be read easily from the backups. And directories that are encrypted are going to be well encrypted only with the mnemonic is going to be safe. Don't store that mnemonic in an unencrypted directory, and don't store that mnemonic inside the encrypted directory, because one of them is going to be totally insecure. The other one is going to be, you can't recover it. You have to find a place to go and store that where it's safe. So let's look at how that's done. If we go into our admin account, we can look at administrative settings and apps. apps, and this is going to be the interesting one. And apps are all kinds of different things you can go and put in. And so there are some that I would definitely encourage. One of them is you can put in anti brute force settings so that you can't simply keep guessing passwords. You get locked out after a couple. There's one that lets you put in OTP, and that's in here somewhere so that you can use a one-time passwords from an authenticator app. And in order to log in, you need to use your username and password. Then you need to use an authenticator app in order to log in. It's great. It prevents the easy kinds of things. But right now, I want to look at, we'll just do a search here for encryption. That should do it. And this is the default encryption module. And if you enable that, it will go and install I guess it's already installed. You just enable it, and that would enable full server level encryption. Excellent documentation. I recommend you read that before you think about it, and it gives you a lot of details on it and also gives you the options of how do I let multiple people read an encrypted directory. And end-to-end encryption is the other one. And we're going to turn this one on so that we can go and show you what that looks like from a user viewpoint. So that is now turned on. And now we can look at how that runs for a user. I've brought up a Nextcloud client that is looking at this particular admin account that we have running in our Nextcloud. And you'll notice it's red because it is not secure. It's not encrypted at all. It's HTTP rather than HTTPS because I didn't set that up. And further, even if it were HTTPS, I haven't put a valid certificate on it, so it's not going to be very happy. But from an encryption viewpoint, we can see that we get a message here that says it supports end-to-end encryption, but it needs to be set up first. And we have 3 directories. We can only set up end-to-end encryption on an empty directory. So the first thing we want to do is go and add a new directory here. We'll just go right smack in the middle here, and we're going to go create a new folder, and we're going to call it encrypted just for chuckles. And we'll now see in a minute here that we have a folder called encrypted there as well. And if we go and we set up encryption, it's going to basically give us this big, huge, long string of words, and you'll want to make sure that you copy those words. I'm not going to worry about it right now, but if I were to, I would go and take that and copy it and then paste it somewhere where I can remember it. So encryption is set up, and at this point we have an empty directory, so we can go and say encrypt this empty directory, and this is going to encrypt this folder. And we now have an encrypted folder, and here I can go in here and I can say we're going to add a new text document, and we're going to call it testme.txt. And we're going to go and edit that and specify, let's bring that into a window where we can see it recorded. And we're going to have a nice, easy to read testme.txt document. And save it and close this. So here in our Nextcloud, we see testme, and if I open it, I can see that it's indeed a test. Oh, that's all great. However, if I were to go to, we're just going to pop this back in here. If I were to go into here, Nextcloud, and I go into CD common, Nextcloud, what is that? Data, admin, files. In files, I can see that I have a directory called encrypted, cd into encrypted, and let's take a look and see what we got. We have some gobbledygook that I cannot read at all. And if I do a list it, I see it has that, not exactly readable. And if I were to continue this a little bit, and I create a new folder in here, and I call it new folder, that's very nice. And in new folder, I can create another text document, and we'll call it 2, and we're going to go and edit in Notepad, hi 2, save it, close that. So here on the Windows PC, when we look at it, we see that we have an encrypted folder. The encrypted folder has a new folder. The new folder contains hi 2. The encrypted folder contains both the test me and there. And we can see that in here, we see that we have new folder and encrypted. But again, we'll pop over to here. And if we now look and see what we have here, in encrypted, we have a directory with some crazy name, and we have that text file we had originally. And if we go into that crazy file directory, we see that it has another different crazy file that we can't read. So this is what's going on in encryption. If I were to now back up and store the entire common directory, it will have only encrypted files. You can't read them at all. I store them offsite somewhere. I make sure I've got multiple copies that are backed up in different places. As long as I have this encryption key, and that's, I can display the mnemonic and I can see it. As long as I have that mnemonic right there, I can recover those encrypted files. And this is going to be done just on the directories I want to have encrypted, and it's end to end. By definition, it's end to end because it's being encrypted on the client PC. Everything from the client PC, the communication to the server, the storage on the server, the communication back to the PC is all encrypted. The encryption and decryption are being done on the client that's on the PC. So the things I like about it are that it is securely encrypted, end to end, only the PC. As long as I have that mnemonic, I have it encrypted, and it's only the directories I want. So other directories that are not of great concern, I can leave unencrypted, so my photos are unencrypted, and so on and so forth. The disadvantage is the only way that I can share is by sharing that mnemonic. And as far as I know, you can only have one mnemonic on here, so that's the weak spot. There's no mechanism to share specific encrypted files with some users and not share other encrypted files with some users. So that's a trade-off you have to make. If you're trying to do that level of complete complex sharing, then you want to be using server-side encryption. It's easy to set up. You'll need to read the documentation because it's got a fair amount of interesting capabilities. It is very mature and works well, but it's a little more complex. At this point, we've set up a Linux system. We've installed Nextcloud. We've got our Nextcloud data on a ZFS pool. We can look at the ZFS pool. We can make sure that it's right. If needed, we can add hard drives to the pool if our data grows beyond, well, in this case, beyond 5.5 terabytes or gets anywhere near it for that matter. We know how to scrub the ZFS, and Nextcloud is running. Now there are some more steps. If you want your Nextcloud server to have a legitimate certificate so that if you go to the Nextcloud server on the web, it shows you a valid lock symbol, then you'll need to get a certificate. Nextcloud is pretty much built to work with Let's Encrypt, which is a way you can get a free certificate. And you can look up, I'm not going to step you through this, it's actually very straightforward. You can look up Let's Encrypt with Nextcloud. The Nextcloud will have to have access to the web in order to go set it up. And that will get you a certificate so that when you go there with your with a browser or with a client, it will basically say, yes, this is legitimate, and we can both encrypt it and we can ensure that this is in fact the correct Nextcloud server for the name that you've used. So I encourage you to look up Nextcloud and Let's Encrypt. And then every 3 months, 6 months, something like that, the certificate expires, and it will automatically go and create a new one for you if you've allowed Nextcloud to go out onto the internet. That is, you allowed port 80 and port 443 to come in from the internet onto that server. If you're running a more secure environment and you're only allowing SSH or VPNs in, then you will not be able to do that automatically. You could still go and get a certificate that matches a name. That's a little bit more work. Or you could decide that you don't have to worry about it because you are on your internal network, and therefore you don't need to worry about a validated certificate. That's really your call. And that's going to be true of a lot of things. If you are deciding to run entirely internally and any remote access when you're on the road is going to be through SSH, then you know a fair amount more about the security of your system. You won't be getting nonstop attacks of your Nextcloud server. You will still be getting nonstop attacks of your SSH server, but that is far more secure. And make sure that you're using authorized keys and you're disabling password logging and through passwords. Passwords are known to be fairly insecure. People will sit there and run password guessers for days and weeks and months. Authorized keys, that just won't work. And you now have a machine with an authorized key that lets that particular machine in. And so as long as you don't have too many machines, that can be managed fairly well. If you're going beyond, 10, 15 machines, then it can begin to become a little bit of a headache, which authorized key is for which machine and are they all up to date and so on and so forth. Then you might want to be looking at a more general VPN approach that allows you to use, there are a variety of methods to do that. If it's of interest, I'd be happy to walk through one of them. There are any number of solutions. And of course, as always, there are any number of solutions to any of these. I walked through Nextcloud. I walked through Ubuntu. You don't have to use Ubuntu. There are plenty of other distributions. You don't have to use Nextcloud. There's OpenCloud. There are many other solutions than that as well. I like these. I think they're good. I think they're reliable. So those are the ones I chose to show you. And with that, we'll end this one. And remember, this is the fourth video of the series. We had the introduction in one. We had concepts of internet protocol in the second. We had setting up your own firewall and router in the third. This one is setting up your cloud. And the fifth one is setting up your own IP security cameras with IP security camera software that will look for events that are happening on your cameras, report them to you if you so desire, and let you store a whole bunch of data from your security cameras securely on your data cloud, or in this case not a cloud, but on your own hard drives, and in a way where nobody else gets to decide who sees what when. You make that decision. Thank you.